Thank you. I'm Jean-Francois Campeau, so I'm in charge of Arene. And today I'm coming to talk about SDV. So what is SDV? For me, SDV is very easy. It's kind of a way to say software is now a first-class citizen of the car, a product that we all know very well, that we've been using for decades. So that's not so much about technology, but more about people, those that use those cars and those that produce those cars. As you could see, my Nihongo is not very good. Even though I've been in Japan for 4 years, it's very difficult for me to learn because it's hard to learn new things. SDV involves that OEMs, traditional OEMs, that have been producing cars for decades, well, they need to learn new things, and that's hard. If you notice about the wouldn't it be nice, anyone have an idea what it means, where it comes from? This ring a bell? No? So that's a very famous song from a very, very famous group that was of a very, very, very famous album, Pet Sounds from the Beach Boys, that was released in the 1960s. But when we talk about the 60s, it's the era of the Beatles, right? And the Beach Boys were there before. And they were losing ground against those guys coming from UK. And then they wanted to change something, but at the same time, they didn't have the guts. So Brian Wilson, the leader of that group, decided to do it by himself, decided to take things into his own hand and to change. He did it consciously, against the will of his manager, his dad, and the rest of the group. And this produced one of the most influential albums in the rock and roll history. But if we take a step back, we can look at the kind of how we evolve Arene, how we integrate it step by step into the massive production system of Toyota. Today, there's about 100 million vehicles of Toyota that are distributed in about, well, many dozens of markets and regulations that produce multi-dozens of product lines, each of which has many, many variations. So this massive, we cannot deploy this all at once, so we need to go step by step. So in the RAV4 this summer, last summer, we launched Arene. As you can see, it's covering the A domain, ADAS, and IVI multimedia as a foundation for the application. So it's a system that is distributed to people who produce the experience that are used by the car owners. So I've been producing what we call software frameworks and platforms for a number of decades now. And my mom always asked me the same question, what do you do at work? And it's not possible for me to answer. I can't. But with SDV, I think I can answer now. That's what I tell her. I said, well, I just make sure that when you use your car, it continues to behave exactly like the last time you used it, even though there was a software update applied on it. And when we think about it, with those hundreds of thousands of variations, we need to make sure that the software that we deploy those cars, well, meets the expectation of, in my case, my mom, but everybody. So we develop this intimacy with our car. We know that car. We understand it. So when we deploy something on it, we can alter this experience. And this is what I'm doing for a living. That's what keeps me awake at night as well, because it's a huge challenge. So for Toyota, as you can see, the SDV, it's more or less a journey well, that leads to zero accident. So it's, again, a very, very ambitious mission. And when we think that products will be updated through software so we can change the behavior, then alter, then it makes it even harder. More concretely for our software, what does it mean? So change two big paradigms, especially. So this is the definition by Kenichi Murata-san, the fellow of Toyota in software. So he defines it as a paradigm shift. I'm going to try to use this thing. So here, this is the legacy way or traditional way. So we design functions based on hardware, and then we sign contracts with suppliers, and then we consider software after. In the future, we consider the software design, so based on the features we want this product to do today, but also for the years to come, as we foresee product evolution through software update. And then we design, the ECU. So the hardware is designed after software requirements are defined and understood. The second big paradigm is probably the most challenging one is, so we have the traditional way of developing the software, and then we release it to customers through software updates. But when we think about this flow of activities applied on hundreds of thousands of variations, then we need to make sure each and every part number, software and hardware, are compatible, and that they will ultimately work well for the end user. So that's another very big challenge. So software-defined vehicle brings opportunities for the car makers, as it allows us to change and evolve the experience of the user of the car. It comes with opportunities, but also responsibilities. For the vehicle owner, well, when we experiment driving in a car, it's a multi-sensory activity that we integrate into our brain, then we feel emotion. And this emotion can be altered by software now. So when we change the software, we can change the behavior of the car, which will lead to a change of our experience and emotions. So it can be positive, so we will actually enjoy, but it can be confusing, can be fearful, can be many things. So we need to make sure that when we push that software to those hundreds of millions, hundreds of thousands of variations, then we maintain this relationship of trust. Because after all, even though it's a software-defined vehicle or not, we want to trust that vehicle. If we alter the software, we make the software not working as the user expects, then it's a break of trust, not in the software, but in the car itself. So why is it difficult? So my mom drives a very old car. She's afraid of technology. And on her car, there's software. There's an ABS, there's a cruise control. There's software. But let's say she's buying a car in 2026, an SDV car. The range of software is much broader. So, and I think this is where we are achieving some limits in the current method of producing cars. And that's what I would like to talk about here. So why is it difficult? Well, because it's not broken. From a traditional OEM perspective, the system works well. So the cars are produced by modules. Modules are tested locally and then shipped to the next assembly line cell or shipped to the assembly line. And then test through multiple layers of assemblies. They are tested modularly. The automotive business model is extremely mature and articulated against this modular engineering approach. It's working well. Everybody understands this. So the suppliers, the OEMs, everything works. It's working. It's really working well. Up until the moment when we apply extensive software and very complex interfaces, then it works very difficultly. It's very difficult to make it work. Finally, why is it so difficult and why modularization doesn't work for software? Because it doesn't. It's because software is too easy to change. It's too difficult to control. There's not enough standardization. And many people can make modification of those interfaces that have tremendous impact on the others, not knowing that they are making this impact. Finally, when we build hardware component or electrical component, there's a lot of handbooks, lots of automation, lots of CADs, and standards. So there's what we call a state-of-the-art. So if we go against the state-of-the-art, then there will be flags raised by quality division, or there will be something that will intercept that. In software, when we make a modification on Ethernet signal, for example, well, it's hard to flag. There's very few standards right now that define the format of this information, the speed. There is some, but it's easy to change. Too easy to change. So how do we ensure that an SDV constantly provides good experience? Again, to talk about my mom, as I said, she's afraid of technology, so sometimes she calls me and she says on the phone, they broke my phone. But you're calling me with your phone. So what happens is, and I'm sure this happens to you, just like it happens to me, there's a software update, changes the behavior of the cell phone a little bit. Some menus change, or parameters, preferences happened last summer in my case. My preferences were all changed. So for many people, a slight change of behavior of that product causes great anxiety. I was preparing a similar talk a couple of months ago, and while I was preparing, I was making my notes early in the morning, last minute, as always, and my computer started to freeze. So it was dead. But I didn't have time to kind of recover. I was in panic mode for a few minutes, panicking. So software, even though it's just a computer, and the computer is really good, the software is good, everything is nice, but that very moment, it let me down. And I was a panic, even though this product cannot necessarily harm me, right? Well, in that day, it did harm me. So what is a customer experience? Well, a customer experience, we hear that all the time. What does it mean? Well, it's an interpretation of the reality that we do. It's an emotion, but it's an emotion integrated through the sensories that we have into our brain at a very precise pace. And it includes anticipation of reality as well. This is a concept of safety. We need to always make sure that we are in a place where we feel safe. So we anticipate what's normal, and then we interpret what we receive as information, and then put that against what's normal. If it's not, then we feel very bad. For example, motion sickness. What happens with motion sickness is there is a desynchronization of the perception of the movement with our eyes and our internal ears. They are not precisely at 1/10 of a second integrated together. So then we feel motion sick. So what our body sends as a message is, get out, ASAP, something's awfully wrong according to your anticipation, you're in danger. That's what motion sickness is. And we can also experiment that. Let's say you cut your lateral vision like this, and then you try to move, you will fear the movement, because that's our way to perceive danger, is from those kind of a perception of the reality. So we know out of our genes and very old times how to feel safe. This is fundamental. We cannot experiment any other emotion if we don't first feel safe. So when I hear things about a car is like a cell phone on wheels, I think it's a bit twisted as a reality, because a phone will not harm you, even though it can create you very big fear and panic, like I experienced. But we know, just from an instinct and survival instinct, that it will not kill us. The car can either kill us or damage people around us or others, society. It's a very fundamental differences. So how and what can be done by the traditional OEMs to actually be able to compete in SDV marketplace? Because that's all about competing. Well, we need to change many things. We need to change the opacity. We need to have the OEM able to specify the product entirely, even the software inside those black boxes that are called ECUs and MCUs. It's mandatory that we have white box so that the OEM can make clear specification of the content of the software in those ECUs, at least from many non-functional requirements, but also functional requirements, performance, latencies, testability, integration, all of those things need to be specified now. We need to centralize information that describes this car completely. It doesn't mean that everybody has access to every information. It should be based on the need to know, but we need to centralize that information, which is currently scattered and fragmented. And this makes the job for engineers extremely difficult. And this is causing a lot of delays, and just because the information is not available for those that need it at the right time. We need to apply agile methods, so we need to accelerate the integration of the software. We need to have more agile ability to change the software, so we need an infrastructure that support that as well. We need to shift left the validation of that software, so when we put it together through agile method, we need to test systematically. Every small increment of software change, we need to test and test again and test again. And then we release, just like an assembly line, to the next assembly line cell that will add software and then test it again, and then it comes back, ultimately with market data. And we need to stop thinking that software tools are disposable, that we need to just get rid and then we have a new model and then we buy everything from scratch, because the tools evolve with the product, because we need to serve software updates for 10, 15 years to come. So when the car evolves, the tools evolve as well. So when there's a part change or hardware change or whatever, the BOM contains the tooling that also evolves. So we need to evolve the hardware, the software of the car with the tooling as well. So tooling is becoming software asset that OEMs should invest in, involve with their product lines, just like they invest in the RAV4, for example. That's been a product line for many, many years now. Well, the tooling, everything that supports the production of the software to the RAV4 should evolve with the product itself. So what is it that Arene is doing about it? So as we saw at the beginning, Arene provides a runtime environment to those who produce those software applications that our customers are experiencing. But producing those applications is very difficult, as we talked about. So we produce also a software production line to support that. There's many, many, many people involved in the production of software today at TMC. There's many roles, and they operate more or less in a silo. So for example, the system engineer will write requirements, and then there's a handover to people, but there's a long time that can be observed at times. So what we would like to do, what we are enabling here, is a bit like for those who write software when Git came, yeah, maybe it's not, you know Git, people know Git, so there's before and after Git. So for everyone that has been building software, creating software, and the most probably important moment that happened in the history of software is when Git arrived. It allowed collaboration, working together in real time, asynchronously, on extremely complex products, software products. Well, this is our aspirational arenas, to enable that for a whole vehicle, for the software and also the hardware, because they evolve together. And so a systems engineer can write specification, and then a test engineer can write the test, and then we have a test that assesses the progress of the product. Of course, the test will fail originally, because we have a standardized environment to test the requirements. We call it test-driven development. And then the vehicle developer, they can implement the function. And then the project manager can report a true status, because it will look at test results, not just, I got the information from the engineer, it's ready, but okay, but how can we know it's ready? So this involves that, as you can see at the center, there's a virtual vehicle. So we need to virtualize those vehicles. It's impossible that we test those hundreds of thousands of variations of those cars physically. But we need to assess the software that is brought to each and every one of those customers and make sure that their experience is maintained. And therefore, we need to virtualize the vehicles now. So we don't just buy ECUs now. We buy an ECU and also a model of the emulated ECU, so that we can put the same binary that runs on the car on an emulated version of the ECU. And then we can scale all of the variations of the ECUs, all of the variations of the board, the form factors of the displays, everything. We can test everything, but in the cloud solutions. So that scales. Of course, it doesn't mean that we remove VN Hills or confirmation vehicle. We just put much more infrastructure up front so that we can assess a series of behavior of the software, compatibility with the hardware, and then there's a subset of functions, especially safety functions. They are being tested on the hardware. So, okay, we do software, we deliver that to cars, but what's the Toyota perspective? So why are we doing that in Toyota? So this is the vision of a digital software center in Toyota. So in this, what it shows, and I think that's why I decided to put that slide there, is how complex this is. It's not just ECUs that communicate together. It's a car that communicates with the environment, the city. It's a car that can detect how I feel and how somebody that I'm about to meet that I don't know, never met before, our car can collide in a merge operation. And our cars will understand this ahead of time using all kinds of infrastructure to actually prevent an accident. So maybe my car will decelerate to let the angry driver come in. Just, we don't notice, it's natural, then it's safe. But if it's well integrated, if the systems work at the right latencies, then we can make it feel that's like seamless to people. But to achieve this, in the context I was describing, with all of those permutations of change and variations, well, we need to have a very good understanding of each of those cars from a software perspective. Their performance as well, we need to understand. Their brake, even wear and tear, we need to understand. So if this guy has, let's say, brakes that are really about to break or something, that we cannot just jump on the brake. We need to understand all those things with software now. We can understand those things. It just makes it very complex. So then the command that will be sent there needs to be filtered out by something, because we know that those brakes are about to fail. So this, we can achieve a lot, but the goal of zero accident involves all of those small details. So it's a very difficult and ambitious goal. So ultimately, what would be great, what we are aspiring to in Toyota using Arene, is that we are able to grow old with our car, that our car ages with us but understands us and understand the society around it, so that we can live a safe and happy life. So that's it for me. Thank you.